Okay, here we go. So what we're going to do now is in the last example we looked at, or I'm sorry, the last video we looked at two examples of kind of how you might see these direct variation problems thrown at you. So what this video covers is one of the things that's powerful about direct variation. Basically looking at rates and equations associated with those rates is comparing things, and that's pretty much the whole point of statistics and everything in math and its regular application in daily life is we use math to help us explain things, to help us figure out if things are fair, if they're right. And it should be an agent of change. It should be something that helps. It shouldn't be just something that purely describes it. It should make us want to do something as a result of it. All right, so these direct variations can be used for that. So let's take a look. All right, so we've got this first question here. New compact car can travel 288 miles on 9 gallons of gas. All right, the distance driven in miles, y, varies directly with the number of gallons of gas, x. All right, so it's saying miles is my y, all right, and then gas is my x. And we know this looking, it's already, the graph's already set up for us, so we're in pretty good shape that way. This situation can be represented by the equation y equals 32x. And then it says, first thing we got to do is graph this. All right, well, if I know my equation that they want us to graph is y equals 32x, okay, basically, if I put 0 into this, right, for x, I've put in the point 0, so I go 32 times 0, I'm going to get 0, right? So I know the origin is one of my points, okay? And then just, I don't know, pick any other point that's on here for gas and see what happens. So let's take 5. Let's see what happens when we use the point 5. And all you need is 2 points to graph something. So you have y equals 32 times 5. And I'm going to do some quick partial products here. So I'm going to do 30 times 5. All right, which is I almost said 300. It's 150. All right, bad math teacher. And then 2 times 5 is 10. So 150 plus 10 is 160. So y equals 160. So I've got the point 5, 160. Let's figure out where that is. So I'm at 5 right here. And I'm going to go up till I get to 160. And it looks like I went by it, but it's about right there. And then I'm going to just get rid of this stuff right here. Okay, and then let's put a line. Let's use I don't know. Let's use pink. I like pink. All right, put a line up there. Here's my line. Put some arrows on the end of it. All right, so we graphed it. So check, done. Okay, and this line will kind of tell me that, well, if I go 9, if I went up here and I look at 9 gallons of gas, it's going to get me, about, I don't know, maybe 300, something like that. And I'd be able to figure that out if I put it into the equation. So how many miles per gallon does the car get? Well, here's the thing about these equations is if you look at them, we know that this number that's in front of the x is my rate. My what do they call that? My direct variation constant, my constant of variation, or my constant of proportionality. So that means that if your rate is always your unit rate, so unit is another way of saying for 1. So if I put 1 into this equation, I would get y equals 32 times 1, and it's 32. And guess what my rate is? My rate is 32. And it's 32 what? It's 32 miles per gallon, all right? Miles per gallon. So how many miles per gallon does the car get? 32. And I'm going to put MPG because that's usually what they use in the automotive industry. All right. Now, letter C. So B is checked off. Letter C, the distance y traveled by a hybrid car using x gallons of gas can be represented by y equals 42x. Which car gets better gas mileage? Well, the better gas mileage would generally mean it's higher gas mileage. And we figured out that our gas mileage is our rate, right? So the rate on this one was 32. Well, if you look at y equals 42x, that means that that car gets 42 miles per gallon, right? And so which car gets better gas mileage? Well, the hybrid, right? So the hybrid gets better gas. I did write hybrid. For a second, it looked like I wrote hybrid. So 42 miles per gallon, and explain. Really, there's not much to explain, but you could say the hybrid gets 10 mpg more than the compact car. All right, so again, not a super complicated problem, but you just got to understand that they're not just throwing these numbers out. And I love it when students look at things like this and just their eyes gloss over and they just say, I don't get it. But you can clearly see if you go through this and just kind of slowly work on it, you can figure this out. Okay? So let's check this out. This next one. Damon's earnings for 4 weeks from a part-time job are shown in the table, and that's this table right here. Assume that his earnings vary directly with the number of hours worked. So earnings varies directly with number of hours worked. So earnings is going to be my Y. So earnings, which is another way of saying what he makes, over hours. So this one actually, if the earnings would be my Y, hours would be my X. My Y is actually down here and my X is up here. Okay? And a lot of times you're going to see they put it up that way. All right? So assuming that he works, he can take a job that will pay him $7.35 per hour worked. Which job has the better pay? All right, so the other job is $7.35 per hour. So what we got to do is we got to look at this table and we got to figure out how much money he's making per hour. Well, remember, the rate, if we can figure out the rate from here, which I think we can, looks to be enough information, that rate is going to give us a number that we can then compare to that $7.35. So let's just take any one of these numbers. So let's take this. Let's take 12 and 9. So we want to put it in, we're going to take 12 and 9, that number, and we're going to put it into this equation, so earnings per hour. So we're going to go Y over X is my earnings per hour, right? Basically how many dollars per hour you make. And so my earnings was 90, and then over for 12 hours. And then so if I divide that in, I know 12 times 7 is 84, and I know 12 times 8 is 96, and 90 is halfway between that. All right, so that means that it's $7.50 per hour is what he's making at his part-time job right now. He's making $7.50 per hour. Okay, now compare that to he can take a job that will pay him $7.35 per hour. All right, well, we know that $7.50 is greater than $7.35. So which job has the better pay? Well, you would say is his first job, right? And it's, he makes, 15 cents per hour more. And I just did a little subtraction problem to figure that out. An interesting application of this, though, is, you would say, okay, well, then he should stay where he's at, right? What if this other job, right, this one right here, gave him more hours? So it'd be interesting to see, like, how many hours he would have to work for it to, for him to break even and all that. So it's, real world problems are a little messier than this one. But just something to get you thinking about, right? Okay, that's it. Thanks for watching.